Good afternoon, everybody. We are going to talk about linear regression today. We'll do some examples. We'll talk about the theory behind linear regression and how it works, how you can apply linear regression to solving real-world problems, and the importance of it. Linear regression is probably, if not the most, definitely one of the most useful regressions that we perform on data set, okay? So what is linear regression? Simply speaking, you try to feed a line, straight line, through a data set that best fits that data set, okay? Linear regression is finding a straight line that fits a given data set, that rather best fits a given data set according to certain criteria. That's what linear regression is. For instance, let me start off with an example. Let's say you go to your local restaurant where you dine, right? So people go there and eat, and they pay tips, based on how much they spend. So let's say this is your X, the dollar amount, the tip, dollar amount that you spend, and Y is the tips that you pay. All right. So now let's say you collect a bunch of data from there and you kind of plot it here, scatter plot. So you find these points. Okay. I'm just making it up. Okay. Etc. So this is the data set that you got. Along the horizontal axis, you got the dollar spent. Along the vertical axis, you got the tips that is given. Now you want to find a straight line that fits best through this data set. Straight line that would be a good approximation of this data set, okay? Or the best approximation. So if I ask Don might say, okay, this looks like a pretty good line to me through this data set. On the other hand, if I ask Jessica, she might say, no, maybe this is a better line. And yet another person, let's say name Jason, says, no, maybe this is the best line. This could be very subjective depending on who looks at it and how you look at it. We want to get rid of that subjectivity. We want to agree on a rule that we could apply to any data set for linear regression. And that rule is this. So let's draw a line. That's any line, it doesn't matter. Then what I'm going to do, I'm going to draw a vertical line from each of these data points. Draw a vertical line. Okay. I drew a bunch of vertical lines from each of these data points onto the straight line, some straight line. Now what I'm going to do, I'm going to take these vertical lines, the length of each of these vertical lines. So let's call these lines L1 through Ln. L1, L2, L3, all the way up to Ln. L1, L2, L3, all the way up to Ln. Okay. Now, what you're going to do, you're going to square them. You're going to square each of them. All right. Once you square them, you add them. You square them and you add them. So what you did, you took the vertical distances from the line, you squared them individually, and you added them. And we call this sum, let's say uppercase L. Okay. So this is the sum of the squares of those lengths, okay? Sum of the squares of those lengths or vertical distances. And our goal is to minimize this L. We want to find a straight line. We want to find a straight line such that the sum of these squared distances is minimized. And that is called the regression line. That is called the regression line. Sum of these squared distances is minimized, and that line is called the regression line. So this is called least square method. Least square method. It's called least square method. Now, this is pretty standard. This is probably the most commonly used rule for coming up with regression line. There are other rules that you could use, but this is probably the most commonly used rule for coming up with the regression line. However, think if you have extreme data points, that means some data points that are too big or too small, those could be significantly affected by squaring. So if you have really some big number for one of the L values, okay, and you square it, then it gets even bigger. So the impact of squaring gets bigger. So in those cases, sometimes instead of using the square, some people would just use L1, absolute value of it, okay, L2, and all the way up to Ln, the absolute value of it, okay? So this is just the absolute value method for finding the regression line. Okay, in that case, you're going to minimize this value. But this is the least square method, least square approach. Okay, that is the most common one for regression line. And we find that regression line, of course, not by hand. We use some sort of calculating devices, such as calculator or computers or some programs to find the least square line or the best fit line. So this is just one example. Now, why do I use this example? I really like this example because this is something that you can easily relate to, okay? This is something you can easily relate to. All of you have been to restaurant, you go to restaurant, you pay tips and this and that. So this is something very easy for you to understand. Now, the equation of this straight line, as you know, equation of a straight line is equal to y is equal to mx plus b, right? Now your algebra knowledge comes into play. Y is equal to mx plus b. Y is equal to mx plus b. Now, in this case, we call it y hat. I'll tell you why. Y hat is equal to mx plus b. Or sometimes they use beta 1, beta 2, or a, b, whatever it may be. But the bottom line is this is the slope-intercept form of a straight line. B is the y-intercept, and m is the slope. Just to refresh your memory in case if you have forgotten about slope-intercept form of a straight line, which is y is equal to mx plus b. So if this is the straight line that's being represented by this, if it goes down, slope is negative. If it goes up, slope is positive. And b is this point, coordinate of this point, which is 0, b. That means the y-intercept. That is where the straight line intercepts the y-axis. On the other hand, the regression example I gave you, it would probably look like this, more like this, right? Of course, you don't go below 0 because you cannot spend less than $0 at a restaurant. So y-intercept is going to be here, and from there on, it goes up as you go to the right. So this is going to be y is equal to mx plus b. M is the slope, b is the y-intercept, again, this point 0, b. All right. So this is what we are looking for. So when we are finding the regression line, in essence, we are finding this these parameters, parameter M and parameter B. We are looking for these parameters, and these parameters are called regression parameters, okay? So for a given data set, you could find a regression line or the line that best fits that data set. Now, why do I need a regression line? Not just for fun, because I have a bunch of data I want to kind of figure out, which line fits it best. Yes, that is part of the reason, but there is a bigger reason. You use this regression line to predict future events, okay? You use this regression line, y hat. So y hat is the predicted value. That's why we use hat. Mx times b. Y hat is the predicted value, and m is the slope, and b is the y-intercept. So you can use this model to predict future events. So for instance, these are the restaurant tips that people paid in the past. Now, if you want to find out how much money someone put in as a tip, if he or she were to spend, let's say, $100 or $50 or $30, you can use this regression model to predict the amount of tips the next person that walks into the restaurant will pay, dependent on how much he or she spends. Is this okay, everybody? Does it make sense? Any question, anybody?
I guess it'll make more sense to me once I see it done in a problem.
Okay.
Yeah, I have to see it applied to the work in order for me to understand.
Okay, great. So let's go ahead and do that. So what we are going to do is this. We can use this model to predict, let's say, restaurant tips. Let's go ahead and do that. Let's bring in the problems. So now this is something. What happened to me? Okay. There's a bit of theory I put here, randomness and this and that. You may just browse through it, see if it makes some sense. Given that I discussed about it, you may be able to figure out something.
I have a quick question for you.
Yeah.
This information that you have on the screen, is that in the Google Drive that we can access, or is it something you?
Yeah,
okay.
It's in the Google Drive. It's in the Google Drive.
Okay, thank you.
So let's say these are the numbers, okay? So these are the tips that people paid for spending X amount of money. So let's say these are XY pairs, okay? First number is the amount of money that they spent. Second number is the amount of tips that they pay. So someone spent $20, paid $3 tip. Someone spent $10, paid nothing tip. Someone spent $35, gave $5 tip, and so on and so forth. So X and Y pairs. X is the independent variable, and Y is the dependent variable. X is the independent variable, and Y is the dependent variable. Now, let's go ahead and do the regression. I'm going to do this problem, but I want you to do this, everybody. Go to Google, okay? And then type in linear regression calculator. Linear regression calculator. Once you type in, the very first thing is a very simple one. I did it earlier in the day. Very simple one, just you'll see two columns, X values and Y values. So just plug in these X and Y values in these two columns, hit calculate, you're gonna get the regression line. That is Y hat is equal to MX plus B. Y hat is equal to MX plus B. So you'll get that regression line. So what is the value of M and what is the value of B? Give it to me. So I'll give you 3-4 minutes to work on it. So please go ahead and do that. Okay, great. Don, looks like you got it. Okay. Go ahead and do the next one, Don. So these numbers are going to be 0.21. I rounded it. Y hat is equal to 0.21. I rounded it to the 100th place. 21x plus 0.45. That's what the regression line. Now, why do I need the regression line? So that I can predict the next event. So that leads to the following question. What if somebody comes to the restaurant and spends $50? What kind of tip can we expect according to this regression model? So, or what should be the tip amount or predicted tip amount? Is going to be 0.21 times 50 plus 0.45. So 0.21 times 50 into 1 times 50 plus 0.45 is 10.95. So according to this regression model, the person who comes in next, okay, and spends $50 is likely to pay $10.95, or roughly about $11 in tips. And that is what the beauty of this regression model. Now, what about if somebody comes in and spends $210? According to this regression model, what should be the tip amount? Now, there is one thing you may want to pay attention here is this. You can use the X value to predict Y only if your X value is within the limits of the X value of the given data. That means the interval that is contained by the X values in the data set. So if you look at the X values in the data set, the smallest X value is 10 and the largest X value is 200. So you can only predict for spending between $10 and $200 because this data set has X values only between 10 and 200. So your regression model will be predicting Y value for X values within this interval only. However, 210 is not in that interval. So you cannot use this regression model to predict tip amount for someone who spends $210. Okay, so that is the thing. Make sure that you are okay with it. Sometimes on purpose, I give this problem in the exam, and the students, without thinking, they just say, oh, okay, it's 210, I have the model, let me put X equal to 210 and calculate the number. No, because this 210 is not within the window of X values. Therefore, you cannot use this model or regression model to predict the tip amount for $210. So be very careful with this. All right, that's all for this one.
Mr. Hussain, I'm sorry. Right after you started doing the math problem here for when you got 10.95, someone came to my front door and I had to answer really quick. How did you get 210 again?
210 is something given to you. Okay.
Okay.
So like here, I ask you to predict the tip amount for X equal to 50, right?
Okay.
Here, I ask you to predict the tip amount for X equal to 210.
Okay, and that applies to the problem that's at the bottom right there with the 5,72, 3,
No, we haven't started that one yet. That one applies to the one that we are working on. See, this one, 210, if you look at the X values, the smallest value is 10 and the highest value is 200. So you can only predict for X values within that interval, 10 and 200, okay? If anything outside of this interval, you cannot use the model.
Okay.
Okay.
Yeah, because it's 210 exceeds the highest number within that data set.
Yes.
Okay. Thank you.
Exceeds the X values in the data set, not just any Y value and X value, just the X value, because we are using the X value for predicting Y value.
I understand. If it were to say predict tip amount for Y equals whatever, then we would be looking at the Y data set.
Right. So now let's go ahead. But remember, why is the dependent variable here though? Dependent variable is the predicted value, okay? Independent variable is the X, okay? That is what you use to predict the value of Y. So you'll probably not be using Y range as much, okay? It's mostly the X range. Now, if you ask me the question, okay, so you're doing this and we are using restaurant as an example. Is there anybody on the face of this earth, any person work at a restaurant as a server or a waiter or waitress, sitting down with the regression model and trying to figure out who's gonna pay how much based on how much they spend next time? I haven't seen one. Have you? And there isn't one. But then why am I using this? I'm using this because it's so simple and easy to relate to, easy to understand. Now that you understand the concept, or you have an idea of what I'm talking about, what it means to regress a data set or find a regression line for data set, okay? You can apply this concept to model demand for products and services, okay? So let's say you go to Target or Amazon, they need to increase their inventory, okay, for the upcoming holidays. Of course, they are going to do some sort of modeling. They do way more complicated modeling than this, but as a simple starting point, you could probably say linear modeling, okay? Demand and supply, okay? So you could do some sort of linear modeling of the things that you need to have ready for the customers. Or even in more complex cases, think if you have some sort of modeling or some sort of regression model that could predict how much the next person going into Amazon website would spend. That is very powerful. That is very powerful. Even though you don't sit down and do the regression to find out how much tips are you going to receive next time a person spends $50, but it is very important for businesses to figure out or predict how much money they're going to get from the customers or how much the customer demand is. And the application of linear regression is all over. This is probably the most, if not the most, definitely one of the most used regression method. Linear regression is easy, it's simple to calculate, and it has a lot of application. It's the linear regression. Now let's go ahead and do the next problem, which is going to be very simple now that we have done one. Don, were you able, or anybody was able to find out what is?
Yeah, I got it.
Okay, go ahead.
It's y equals 3.04.
Y hat, Don.
Yeah, y head. Sorry, y head. I gotta get used to saying that. Y head equals 3.04 plus 04x plus 52.60.
Okay, there you go. That's exactly what it is. So the regression model for this problem, where first is the X, second is the Y. X is the number of hours that a student studies, Y is the score that a student receives in the midterm. So if somebody studies 5 hours, get 72. Studies 3 hours, get 50. Studies 15 hours, get 90. Studies 13 hours, get 95. Do you see that? And if you use this model, this data set to create regression line, this is what you get. So now let's say, what would be the predicted score for somebody who spends 11.5 hours? Now, first of all, you look at the data set. Is 11.5 within the range of X values? The answer is yes. The smallest X value is 3, and the largest X value is, I guess, 15. Okay, so 11.5 is within that range, so you're okay. So it's gonna be 3.04 times X is 11.5, right? Plus 52.6. 52.6. So 52.6 plus 3.04 times 11.5. That is 87.56. So predicted value for this amount, for this student who studied 11.5 hours is 87.56, or roughly about 88. That is what the model predicts, okay? And this modeling is pretty much everywhere nowadays, okay? When you are talking about self-driving cars, okay? They're doing some sort of modeling, not that simple modeling like linear regression modeling so much. They're doing complex modeling to identify, to figure out, oh, okay, the next item I see, is it a human being in front of the car or no? Okay? Or the next image that I get from in front of me from the camera, is it a car or is it some other object? So they are using modeling to identify things. You are just starting off with the simplest, world's simplest modeling, which is regression modeling, okay? Linear regression. So we just give you X and Y pairs, and you find that line that best fits through this data set. Now, what would be the predicted score for somebody who spent 16 hours studying for this? What do you think? What would that be? Don, are you trying to say something? I can't hear you.
No, sorry. I have it on unmute by accident. I'm working on the problem as you speak right now.
Okay. So what is it going to be for x equal to 16? What should be the score for the student?
Do you want a number amount?
Sure, if you want to.
107?
Okay. So you just discovered a problem, right?
Yes.
Exams are typically out of 100. You cannot get 107 just because you studied 16 hours.
Right. They got extra credit.
No, they didn't get extra credit. Remember what the problem is? The number 16, x equal to 16, is not within the window of x values. The smallest x value is 3, and the largest x value is 15, right? So you can predict values for x that lies between 3 and 15 only. You can predict values for x that lies between 3 and 15 only. Remember that? Is it making sense, guys?
Yeah, that makes sense.
Everybody else? Is it making sense? Good. Any question about the regression stuff? Anybody, any question about these regression materials?
None. Seems pretty simple.
Yeah, it is simple, yet it is very powerful. Linear regression is a very powerful tool. Okay. All right. So that's all I wanted to cover for today. So that should be it for now.